Hello everyone, welcome to Explore HOP. So for this example, we're told that in a large population, 10% have a rare disease, 75% are not colorblind, and 30% have either a rare disease or are colorblind. What is the probability of a person being colorblind given that they have the rare disease? So let's first start by defining the following events. Let's let event D be the event where a randomly selected person has the rare disease. So this is the event where person has the disease. And we'll let event C be the event where a randomly selected person is colorblind. So event C will be the event where person is colorblind. Now, let's determine the probability of some of the events we just defined. So we have that the probability of event D, which is the probability of a person having the disease, is equal to 10%, because we're told that 10% of the population have the rare disease. So this is equal to 10%. The probability of the complement of C is equal to 75%. That's because we're told that 75% are not colorblind. So that's just the complement of C. So we write that the probability of the complement of C is equal to 75%. And this of course means that the probability of event C is just equal to 1 minus the probability of the complement of C, which is just equal to 100% minus 75%, which is equal to 25%. So the probability of C is just equal to 25%. And we also know that the probability of the union of event D and C is equal to 30%, because we're told that 30% of the population have either a rare disease or are colorblind. So the probability of the union of event D and C is equal to 30%. Now, we want to find the probability of a person being colorblind given that they have the rare disease. So to do this, we want to find the probability of C given D. So we want to find the probability of event C given D. And to do this, we know that the probability of event C given D is just equal to the probability of the intersection of event D and C divided by the probability of event D. But first, we must find the probability of the intersection of event D and C. So we first want to find the probability of the intersection of event D and C. And to do this, we're going to use the formula where the probability of the union of event D and C is equal to the probability of event D plus the probability of event C minus the probability of the intersection of event D and C. And from here, we can just solve for the probability of the intersection of event D and C. So the probability of the intersection of D and C is just equal to the probability of event D plus the probability of event C minus the probability of the union of D and C. And we get that this is just equal to the probability of event D, which is equal to 10%, plus the probability of event C, which is equal to 25%. And then minus the probability of the union of event D and C, which is equal to 30%. And this is just equal to 35% minus 30%. which is equal to 5%. And now we can go ahead and find the probability of C given D. So therefore, the probability of C given D is equal to the probability of the intersection of D and C divided by the probability of event D, which is equal to 5% divided by the probability of event D, which is 10%. And this is equal to 5 over 100 divided by 10 over 100. Which is equal to 5 over 10, and this is equal to 1 over 2. And this gives us the probability of a person being colorblind, given that they have the rare disease. And that's it for this example. Thank you for joining us. See you in the next lesson.